Today I'm here to explain about this question. Find the derivatives of the functions. So let's start with number one. Some of you might think this is really easy to find this one. You can just maybe just find the derivative of each term here. So for example, the derivative of 3x squared is 6x and plus 0 times 2 times 3x squared plus 0 and 6x times 6x squared and 36x cubed. Actually, this is wrong answer. You can't do like that. If there's multiply between them, you can just simply find the derivative. If each terms are separated, for example, y equals 3x squared plus 3x plus 2 plus x to the power 4 or something, you can just find the derivative of each terms. But if there's any like divisions or multiple, you can't just simply do that. So what would you do? You have two options. First one is you can just expand this function. Like it's going to be 6. You can just multiply these like this. Then it's going to be 6x to the power 5 negative 3x squared plus 4x cubed negative 2. Then now we can simply find the derivative, or you have two, like I mentioned, you have two options, and the other one is easier, which is called product rule. It's a little bit, it looks complicated. Let me just write the formula of this product rule. If you want to find the derivative of some product things, like some function times some function, it's going to be f prime of x times g of x plus f of x times g prime of x. It might look complicated, but if you remember that, it's actually easy. So in this case, f of x is 3x squared plus 2, and g of x, is 2x cubed negative 1. So technically, this one is f of x times g of x. So let's find a y prime. And it's the first time, so let's just solve this question with this, while just reading this equation. So to find the derivative of this function, first you find y prime of x. Y prime of x is 6x plus 0. So you can just put 6x times g of x. So you can use this one as it is, 2x cubed negative 1. Plus, next one is f of x. So you can use this one as it is, 3x squared plus 2 times g of x. G prime of x is 6x squared. They can just expand it. 12x to the power 4 negative 6x plus 18x to the power 4 plus 12x squared. And let me simplify. 30x to the power 4 plus 12x squared negative 6x. Yeah. So it's not that difficult actually. You can just expand it sometimes. Probably this case, for the next question, number 2, it might be easier to just expand it. So it's up to you which way you use. So, but in this case, let me use product rule first. So f of x is 3 negative 2x, and f prime of x is negative 2, and g of x is square root of x, and g prime of x is, this one is x1 over 2, x to the power of 2, so 1 over 2 times x to the power of 1, so negative 1 over 2. Okay, then y prime is f of x negative 2 times square root of x plus 3 negative 2x times 1 over 2 times x to the power of, so it's going to be 1 over square root of x. Okay, then negative 2 square root of x plus 3 over 2 square root of x negative square root of x. Yeah, that's it. But like I mentioned, you can just use product rule. So let's compare. Let me solve this question. I'm sorry, without using product rule. Y equal, let me 3 negative 2x times square root of x. Let me just expand it first. 3 square root of x negative 2x to the power of 3 over 2 this times, because it's going to square root of x cube, because you can just change it, square root of x squared. Yeah, so it's going to be like this. And the y prime of this one is 3 times 1 over 2 times x to the power of negative 1 over 2, and negative 2 times 3 over 2 times x to the power of 1 over 2, which is actually this is wrong. You can just simplify these. So the answer is going to be negative 3 square root of x plus 3 over 2 square root of x. Okay, then 3 over 3, oops, negative 3 square root of x. That's it. In this case, just expanding might be easier than just using product rule, but in some cases, for example, if you have the function like this function, it's obviously easier to use product rule, so it's up to you. So but it's better to know, it's better to remember this function, this equation, product rule.